Welcome. So now I'm going to discuss that next name reaction that is related to carbohydrates, and that is pinacolone rearrangements. So what is the like I have told that for dienol rearrangements, or maybe uh, division of rearrangement. For that, what we know that we should know remember the setup. Okay. So like if I say that for division of rearrangements, what was the setup? So in order to remember that name of the reactions, okay, you just remember the setup. For division of rearrangement, what is the setup? That any this group is there, and here amine group is there. Okay, with that the reagent is HNO2 or NaNO2 or HCl is there. Then that what you should do that remove nitrogen gas. So this is the remove nitrogen gas and that carbon and form carbohydrates. Okay, this is the for dimension rearrangement. Similarly, for diene and phenol rearrangement, what is the setups? So this is the setup for the dimension rearrangement. Okay, and remove the nitrogen gas. This is the setup for dimension rearrangement. Similarly, for that case of diene and phenol rearrangement, what is the setup? That is this dienol means two double bond will be there. With that ketone group is there. Okay, and that it should be very important that this and this has to be conjugation. Similarly, this and this has to be the conjugations, and acidic medium is there. Then that is called the dienol phenol rearrangement, and the product form is phenol. Okay, so that is for the case of the dienol phenol rearrangement. And now what I'm going to discuss is about of that pinacol and pinacolone rearrangements. For pinacol and pinacolone rearrangements, the setup is very simple. Here what you see that pinacolone rearrangement. Here the two carbon atoms will be there. Two carbon atoms and what that and two adjacent carbon atoms OH will be there. Okay, OH will be there. Here some other groups is there will be there, but important is that at these two carbon atoms that two OH group will be there, and the medium should be acidic, that is any acid will be given. Okay, so the medium should be acidic. Then this the pinacol and pinacolone rearrangement will be happened. And another thing, the important is that whenever you do the protonations, that is here also lone pair is there, here also lone pair is there. Now which will do the protonations? So here let's say here that this is R and this is R dash and this is R double dash and this R triple dash. Then which OH will be do the protonations? Which OH? Either this will do or this will do. So that actually how we decided that without rearrangement. So protonations of OH, which will happen that without any rearrangement after the protonations, after that here that living groups, after this protonations it become a water. It means that it will release, then carbon will form. So that protonation of OH, that will happen that where the carbon form, that should be a stable, and that should not be with rearrangement. Without rearrangement, okay, without any rearrangement, carbohydrate should be stable. Okay, so that that protonation, that will do the protonations. Okay, so that we will understand by looking the examples. So this should be very important, that without any protonation, that without any rearrangement, that OH should be that carbocation should be stable. On that case, that OH will do the protonations. Okay. So what we have to remember for that kinds of pinnacle rearrangement, that is at the two carbon center, adjacent to two carbon center, that two OH group will be there and medium should be acidic, and without proton, and what which OH will do protonations? It means that without any rearrangement, carbocation should be stable. That OH will do the protonations. Okay. So we will take the examples to clear more. Let's take these examples. Now in this case, what you see that both the cases, here also CH3, here also CH3, here also CH3, means that these OH are symmetry. Here symmetry is there. It means that here anyone can do the protonations. If both are equal, then anyone can do the protonations. So we will do this one. Then what we'll get here, CH3, CH3 and OH. This is going to be CH3 and this is going to be CH3 and this is going to be OH and H. Here we will have the positive charge. Okay. So here what will happen, that this become a living groups, so it will release. So this we want to get that CH3 and CH3 and this is going to be OH and this is going to be CH3 and this is going to be CH3 and here we will have the positive charge. Now what will happen, that these carbocations, and if this carbocation it will shift, then this is stabilized by plus M effect. This is 3-degree carbocation, but if it is goes to here, then it will stabilize by plus M effect. So that methyl shift will occur. Methyl shift. Then what will get here, CH3 and here OH. Here we have that positive charge. Then here CH3, here CH3 and here CH3. Okay, so this is stabilized by plus M effect, and this is the 3-degree carbocation. That's why this methyl shift will occur, because plus M effect is more than 3-degree carbocation. That is stability of carbocations. So now what will happen, that so now what will happen, this lone pair electrons is there, so this will donate here. That's so this is going to be C, here CH3, here CH3, here CH3 and this is C and this is CH3 and this is going to double bond over and H. This is going to be a positive charge. Okay, now this is a release here, so our final product will be this C double bond over, this is CH3 and this is C and this is CH3, this is CH3 and this is CH3. So this is the final product for this question. So likewise we will solve that. Okay, so what have we have seen here, that both the cases OH are same. That's why anyone we can do the protonases. Okay, we note that if you not remember the name of the reactions, pinacolone rearrangement, it is fine, but you should know the setup. This is the setup, then this will happen. And if you know the concept of organics, then we can easily solve that, because why this rearrangement will happen, because here it will get plus M and this is the 3-degree carbocations. That's why methyl shift will happen. After that this lone pair will share. After that this is the product will form. Okay, so for the pinacol rearrangement, what we see, that adjacent to two carbon atoms, two OH group will be there. Okay, and that OH will do protonations, which is for most stable carbocations without any rearrangement. Okay, so that is the about of this pinacol rearrangement. Now looking at the next examples, what we see here, you see that previously that both the OH were same, but now we see that here in this OH, this here pinyl is there, here pinyl is there, and for this OH this is CH3 and this is CH3. So for this case we will look that which OH will do the protonations. So what I am said, that OH will do the protonations which give the most stable carbohydrates without any rearrangement. So here, if this will do protonations, means if this will become water and it will release, then here carbohydrate will pump, and that carbohydrate is stabilized by phenyl rings. So phenyl ring means that will give that resonance is there. Okay, and in this case, if this will do the protonations, then what it will get, that uh, this carbohydrate is stabilized by that is 6 alpha hydrogens or inductive effect. So now we know that first will be that resonance, then we will have that hyperconjugations. Okay, it means that this will do the protonations, this will not do the protonations. Okay, so now this will do the protonation, because here this is stabilized, this carbohydrate will be stabilized by resonance, whereas here this carbohydrate is stabilized by the 6 alpha hydrogens. Okay, so this will do the protonations. So what will be the product here? That is going to be here OH2, this is going to be positive charge, and here we have that phenyls, here we have phenyls and COH, here we have that CH3, here we have that CH3. So this will release here, then this phenyls and this phenyl, and this is positive charges here, and this is OH, and this is going to be CH3, and this is going to be CH3. So now what will happen after this? Now we will do that. This methyl shift will occur, because after that it will stabilize by the Clausen effect. Okay, so methyl shift will occur. So now here what it was stabilized by resonance. Okay, but now here it will stabilize by the Clausen effect. So that's why that methyl shift will occur. So here we see that here we have that phenyls, here we have the phenyl, and here we will get CH3, and this is going to be that OH, and this is going to be positive, and this is going to be CH3. So this will share here. Now what will get, that pH, and this is pH, and this is CH3, and this is going to be the CO, and this is going to be the CH3. So this is the final product of this questions. So likewise, we can solve the questions related to pinacol and pinacolone rearrangement. Now moving to the next questions. Now look in these questions. Here this is that electron withdrawing groups. This is electron withdrawing groups. Okay, and this is give that resonance effect. And now this is the 1 degree carbohydrates. So here, although this is electron withdrawing group is present, but here resonance is there. So this resonance is more stable than 1 degree carbohydrate. But if resonance is there, and resonance is there with so what do you write here? Resonance is there plus what is there? Electron withdrawing group is there. So electron withdrawing group, actually what this will destabilize the carbohydrates. Destabilize carbohydrates. But here we have the resonance. So resonance plus electron withdrawing group is more stable than 1 degree carbohydrates. But if resonance is there and electron withdrawing groups are there, and if it is 3 degree carbohydrates, then that is more stable. So that we should remember. So here what is that? And if 2 degree, then also that is, if resonance is there plus electron withdrawing groups, and this is more stabilized than 2 degree carbohydrates. So if 3 degree carbohydrate, then that will stabilize. So here, since this is 1 degree carbohydrate, so this will do the protonation. So in pinacolone rearrangement, we should keep in mind that which OH will do the protonations, and that OH will do protonations where we will get the stable carbohydrates. So here this will do the protonations. So what we will get here? COOET, and here pH, and this is going to be OH2 positive charge, and this is going to be that CH, H, this is going to be the OH, and this will release. Then what will get here? C, CO08, and this is going to be pH, and this is the release. So this is carbocations. This is CH, CH, and this is OH. Okay. So now that which will do that, penile shift will occurs or CO2 will be shift. So for that, if you get confused about of that migratory aptitude, then what will do that? Make that two products. Okay. If let's say penile will shift and it says that COT will be shift. So see that if penile will shift, then what will get here? Oh, okay. No, no, sorry. This will shift, right? So what? Hydride will shift because this carbocations this will shift. So hydride will shift because OH will not shift because this carbocation will go, then that is stabilized by plus electrode. That's why we are shifting this carbocation to here. So hydride shift will occur. It means that here COET, here we have that pH, here we will H will shift, and this is going to be that H, and here OH, and this is going to be the positive charge. So here what will get that? This will go here. So we'll get that pH, H, and this is going to be CO and H. So this is the final product for this question. So likewise, we will solve the questions related to pinacol and pinacolone rearrangement. So note that in adjacent to 2 carbon, OH group will be there. Okay, here the 2 adjacent carbons, OH group is there. Then we will do that pinacolone and pinacolone rearrangement, means like this procedure we will do that. So this is the actually, if you don't know about of that pinacolone rearrangement also, we can solve these questions because we know the concepts that this OH will be do that and that protonations will happen. Only the benefits, if you know, if you memorize about pinacolone rearrangement, then the thing is that the doing wrong, the chances is very less because we know about of this rearrangement. That one that OH will protonate, which has that which will give more stable carbohydrates, and after that 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 carbocation will shift and then we will make that groups. So if you know that rearrangements, then if you know this name reactions, then that is the benefit that we will solve it very quickly and chances of doing wrong is very less. Okay. Otherwise, if you don't know and if you know the concept, then also we can solve the questions. But better that you should know this the name reactions, pinacol rearrangement, so that we can solve the questions very quickly. Okay. The next question is this. So here what you see that now this is become a 3-degree carbohydrates. Previously that was 1-degree carbohydrates. Okay. Now in this case this OH will do the protonations, not this, because what I say that electron withdrawing groups with resonance that is more than one, that will be more stable if it is 1 degree or 2 degree, but if 3 degree then that will be less stable. So now this will do the protonation. So what we will get here? COET, and here we have pH, and this is OH, this is going to C, and this is going to be CH3, this is going to be CH3, and this is going to be OH2, positive charge. And now what will happen? This will release. So what will get here? COET, and this is pH, and this is OH, and this is going to be the CCS3, and this is going to be CS3, and this is going to be the positive charge. So now what will happen that yes, now we will look that either pH will shift or CO2 will shift. Okay, here if you confuse about a migratory aptitude, shift both things, pH and COET. So if pH will shift, then what will get? So COET, and here we have OH. Let's say this is positive charge, and here CS3, and this is phenyls, and this is CS3. So in this case this carbon is less stable because COT, this is the electron withdrawing groups is there, so this is going to be less stable, although this is there but electron withdrawing group is there, so this is less stable. So I think this will not fall, this will not fall, and this will fall. Okay, COT will be shipped, this will not shift. It means that what you will get here, if COT will shift, then what will get here, that C, here we have pH is there and OH is there, and we have this positive charge, and here we have that CS3, here we have that CS3, and here we have that CO18. So now what will happen, that this is going to be that C, here we have that pH, and this is going to be that O, because this will donate here, so that is going to be double bond O, and this is going to be that CS3, and this is going to be the CS3, and this is going to be the CO18. So this is the final product for this question. So likewise we will solve the questions related to Pinacol and Pinacolone rearrangement. Now we will solve the last questions. After that we will go for the another name reactions related to carbohydrates. So in these questions what we see, that here also OH is there, here also OH is there, so which will do the protonations. So see that here, okay, in this this is, if this will be released, if it will do the protonations, then this carbon is stabilized by how many, here one hydrogen is there, two hydrogen is there, and here also two hydrogen is there. So if this will release, it will stabilize by 4 alpha hydrogen. Now if it will do the protonation, then it will stabilize by this hydrogen, this hydrogens, and this hydrogen, means here 3 alpha hydrogens. So now you tell me that which will do the protonations. Obviously this will not do, because hyperconjugation, although inductive effect is there, but hyperconjugation is more stable than inductive effect. So here that hyperconjugation is 4, and here hyperconjugation is 3. So this will not do, this will do the protonations. It means that this will do the protonations. So what I will get here, okay, so this is going to be the OH2 positive, and this will remain as it is, and here we have that CH3. So this will release here, then what we will get now, this one, okay, here we have that positive charge, and here we have that CH3, and here we have that OH. So now what will happen, that we can do the ring expansions. It means from here I can write 1, 2, 3, 4, 5, and 6. So I can do the ring expansion. So how I will do the ring expansion, that I have discussed already. So if I will do this one and I want to do this, okay, 1 and 3 I want to do ring expansion, so this will break, so this is going to be the positive charge. Okay, so what I will do now, this is 5-member rings, and from 1 to 3 that will do the ring expansion. So 1, 2, 3. 1, 4, 5, 6. Okay, so this is 1, and this is 3, and this is 4, this is 5, and this is 6, and this is 2, and 2 will get the positive charge, and this will get the positive charge. So how you can remember that one other way that to do ring expansion, wherever positive you will get, that's you will break it. Okay, wherever you say positive negative make bonds, and positive break the bond. That's why I break that 1, 2 bonds, and I will make that 1, 3 bonds. Okay, Now what we will do that here positive charge is there, also at the 2 OH is there, here also that OH was present, here positive charge is there with that OH is there, and at the 3 we have that CH3. So now what will happen that this will give the lone pair, then any ring expansions. No, so you can solve this one. 1 1 2 3 4 5 6, and this is going to be the O, and this is going to be the CH3. I think this is the final product. Let me check. Yes, so this is the final product of this case. Okay, so why ring expansion is not you will not do. If I do the ring expansions here, then what is the problem? Let's say this is 1. If you want to do ring expansion, then that OH, that plus M if I do will not get. Let's say I'm doing ring expansions. Let's say this is 1 2 3 4 5 and 6, and what I will do that, let's say 1 and 6 I want to make bond negative, and then I